Voyager 1 is on a crash course with no brakes. It's currently hurtling through the depths of space that no human-made object has ever been before. And it won't stop until something gets in its way. Like this alien planet it's about to crash into 75,000 years from now. You're about to see how the heck it got there and what happens when it does. As of today, Voyager 1 has been drifting through space for nearly half a century. It traveled to the edge of our solar system and then left us in the dust as it ventured out into interstellar space. The space probe's only modus operandi is to keep going, and going, and going. In 40,000 years, it's scheduled to pass a star that it wasn't even aiming for, and continue into the void. And pretty soon, Voyager 1 will be so far away from Earth that humans will lose all contact and lose track of its location, making it anyone's guess as to where it travels to next. So what if, during its interstellar adventure, the spacecraft makes it all the way to an alien planet? And not just any exoplanet, the closest one to Earth, Proxima Centauri B. It's only a mere 40 trillion kilometers away after all. Would it simply bite the cosmic dust, come face to face with a comet? Or could it somehow survive, leaving behind an important message about humanity for extraterrestrial life? Well, before we can find out, Voyager 1 is going to have to take the longest journey in the history of spaceflight. So strap in, because things are going to get a little far out. Let's start here. See that tiny dot? The one that looks like a speck of dust that some clumsy camera guy forgot to clean off his lens? Well, look closer, because that's Earth. This iconic photo, known as the pale blue dot, was taken by Voyager 1 in 1990 when it was 6 billion kilometers away from us. And it sure has a way of putting our significance into perspective, or lack of significance. This photo is just one of over 67,000 incredible images that Voyager 1 and 2 took of space, transforming our understanding of the solar system, giant outer planets, their rings, and 48 of their moons. It's hard to overstate how much knowledge these probes have given us about life beyond our Earth. Their original missions were only supposed to explore Saturn and Jupiter, and the spacecrafts were only built to last 5 years. But incredibly, they've kept going, breaking new records every day and beaming down new discoveries. Pretty cool. Right now, as Voyager 1 is over 25 billion kilometers away, its signals take 23 hours to reach Earth. But that's about to change. In November of 2026, Voyager 1 will reach an historic milestone and officially become 1 light day away, meaning a signal sent from NASA will take 24 hours to reach the probe, and another 24 hours for the ping to return. To put this into perspective, the amount of time it takes for a signal to reach the moon is 1.3 seconds. To reach the sun, it's 8.5 minutes. So, yeah, I'd say Voyager 1 has been putting in some serious mileage since its launch in 1977. To achieve these feats, it's had a need for speed, moving at a velocity of 61,000 kilometers per hour. That's 38,000 miles per hour. But even flying at these rapid rates won't make its new adventure a quick one. To get to Proxima Centauri B, Voyager 1 will have to spend about 75,000 years in space. That's because this exoplanet, Proxima Centauri B, is located in an entirely different star system, Alpha Centauri. Here, Proxima Centauri B is one of the planets orbiting the red dwarf star Proxima Centauri. Now, Sure, it's technically the next closest star system to Earth, but it's still 4.5 light years away. Now, to start its journey, Voyager 1 has had a bit of a head start. It's already orbiting beyond the heliosphere. That's the sun's shield of armor from harmful radiation and cosmic rays flying through the rest of the galaxy. This big bubble around our solar system is created from the outward pressure of solar wind, and it's the final boundary before interstellar space. Voyager 1 and its twin vessel, Voyager 2, are the only spacecraft to ever have gone past it. Voyager 1 crossed this threshold in 2012 and kept on trucking. And with every new boundary it crosses, its 10 scientific tools on board beam us Earthlings new information about space. Its magnetometer measures the strength and direction of magnetic fields. These readings are how we know that it passed the heliosphere. Its cameras gave us the first detailed looks at Jupiter and Saturn, and its high-gain antenna is what has allowed NASA scientists to talk to Voyager all these years. Some of these tools have been turned off to extend their lifespan into interstellar space. This is essential because not only is Voyager sending signals from space, it's carrying one hell of a special message to space, the Golden Record. This onboard time capsule is full of photos, musical recordings, and scientific data about us humans. Think of it like the greatest hits of humanity. If alien life on another planet discovers the Golden Record, it'll give them a jaw-dropping glimpse into life here on Earth. Assuming they have jaws. Maybe tentacle-dropping? But here's the problem. Right now, Voyager 1's flight isn't on course to any planet. Its current path is headed toward the star AC plus 793888, also known as Gliese 445. But that star doesn't have any confirmed planets orbiting it. So Voyager 1 would need to change its direction. And that direction is about to enter the realm of our cosmic imaginations. Around 2036, Voyager 1 will be so far away that NASA scientists expect to lose its signal. Not because it's running out of the solar system, but because it's running out of power. Its energy supply comes from radioisotope thermoelectric generators mounted on a deployable boom. These convert heat from natural decaying plutonium into electricity. Pretty amazing. But they've been weakening over time, losing about 4 watts of power every year. In iPhone terms, that's like being at 1%, and that old frayed charger you've been holding onto for dear life is about to go kaput. After the last signal is received on Earth, Voyager 1 is now just a silent, drifting monument of humanity, essentially a ghost ship. But unlike a ghost, it can't just disappear into thin air, because there's no air in space. To get on the right track, Voyager 1 will need some sort of gravity assist. Like a slingshot, a gravity assist can add or subtract momentum to shoot a spacecraft in a different direction, change its trajectory. Artemis 2, the most current mission to the moon, used a gravity slingshot to change direction 180 degrees at the peak of its journey. A gravity assist is how Voyager 1 was able to reach interstellar space in the first place. By passing Jupiter in 1979, it gained 10 kilometers of speed per second and another 5 kilometers per second when it passed Saturn in 1980. While flying by these two gas giants, it essentially stole some of the planet's momentum by being sucked into their gravitational pull and spit back out again, like getting a speed boost in a video game. What's even more incredible is that scientists designed this effect. Known as the Grand Tour, Voyager 1 and 2 took advantage of a once in every 175-year alignment of planets, making pit stops to refuel on gravity and soar onto the next, reaching distances impossible by a conventional rocket. Now, the flybys of Jupiter and Saturn not only increased Voyager 1's speed, but in the process, discovered 2 new moons of Jupiter, Thebe and Metis, plus 5 new moons of Saturn, and a new ring named the G ring. Back to Voyager 1. To start altering its course toward Proxima Centauri B, it's gonna need to fly by something. But not just any wee star or asteroid. It needs help from one of the big boys, an undiscovered rogue planet in the Oort cloud. The Oort cloud is located about 5,000 times further away than the distance from Earth to the Sun. So, yeah, not exactly what you would call a stone's throw. It's so far that it's best not to measure it in kilometers or miles, and instead use astronomical units, AU for short. As we've talked about on this channel before, 1 AU, astronomical unit, is the distance from Earth to the Sun. It's about 150 million kilometers, or 93 million miles. Scientists estimate that the Oort cloud's inner edge is about 1,000 AU from the Sun, and its outer edge is about 100,000 AU. And not to be morbid, but, well, I'll be dead by the time Voyager 1 reaches it. It's gonna take 300 years. As Voyager enters this new frontier of the Oort cloud, our sun now just looks like a tiny twinkling star. And I hope you packed a winter jacket for this ride, because things are about to get chilly. Temperature here may be as cold as minus 268 degrees. That's minus 450 degrees Fahrenheit, or 5 Kelvin. Trillions of icy objects surround Voyager like moths at a porch light. These 4.6 billion year old frozen bodies are thought to be pristine relics left over from the formation of our planet, before gravity ejected them out past the borders of our solar system. Many of these objects are actually comets, an estimated 100 billion of them. And once something disturbs them, these volatile, dirty snowballs can go shooting off in any which direction, putting Voyager 1 in their crosshairs. Terrifying. Well, luckily for our venturing vessel, this exorbitant number of comets is spread out over an insanely vast surface area, helping it dodge disaster. Your chances of winning the lottery are 100,000 times greater than Voyager 1's chances of getting blown up into spacecraft confetti. After being neighbors with comets for 30,000 years in the Oort cloud, Voyager 1 finally encounters the gravity assist it's patiently been waiting for. A rogue, undiscovered planet lurking in its depths. Snagged from another solar system by the sun's gravity, a Neptune-like planet has come to call the Oort cloud home sweet home. Ah, cozy ice debris. The lonesome planet, though, is a sight for Voyager's sore eyes. And if you want to know more about this rogue planet, well, make sure to subscribe, because we've got a whole video coming out about Planet 9, featuring someone.
Someone cool, more like.
Sure. Moving on. By flying behind Planet 9 and into its gravity well, Voyager 1 lands its one-way ticket out of the Oort cloud, and in the process spins itself in a new direction. Destination? Proxima Centauri B. This kind of stealthy maneuver has been performed before by Voyager 1's twin, Voyager 2, when it passed Neptune's North Pole in 1989 and changed its trajectory by 45 degrees. Okay, at long last, through the Oort cloud, Voyager 1 enters another Oort cloud, the one surrounding Alpha Centauri, where Proxima Centauri B is located. Now, the length of this boundary is a little blurry, so let's give it another 10,000 years or so to get through it. After 40,000 years of travel, Voyager 1 has a new problem. As if hanging out in a snowstorm of comets wasn't bad enough. Its 40,048-year-old body, made of aluminum, is being put to the test. Now, space doesn't have oxygen to rust metal, but it does have galactic cosmic rays. These tiny superfast particles are menacing cosmic bullets of radiation, flying through the vacuum at light speed, getting fired by explosive events like stars going supernova. And they're a lot more intense beyond the heliosphere. Having now been outside that protective bubble of the sun for tens of thousands of years, Voyager 1 is no stranger to being pummeled by them. These particles have been causing long-term defects to the spacecraft, making it as brittle as a ceramic plate. One tiny impact in space would shatter it. Its risk of crumbling now is worse than a Love is Blind marriage. Seriously, Love is Blind? Is people still watching that show?
Oh yeah, it's like the #1 show on Netflix.
Number one?
Yeah, when it comes out with a new season, it's like premieres as #1.
How many marriages last?
It's high, it's like 60%.
Wow, there you go. Well, all right then. Well, crumbling like a Nick and Amanda wedding. No? That's not them? I'm more of a Survivor guy anyway. Okay, since I'm a betting man, let's say that Voyager 1 does make its date with destiny. 75,000 years, 10 dead scientific tools, and a trillion dodged comets later, it finally approaches Proxima Centauri B, and things are about to get lit. No, like literally lit. It's hurtling toward the side of this planet that has 30 times more extreme UV radiation than Earth. Add sunscreen to the list of things NASA should have sent with Voyager on this flight. And that daytime heat won't be cooling off into the nighttime. Because Proxima Centauri B orbits extremely close to its star, Proxima Centauri, it's tidally locked. That means its rotation rate matches its 11-day orbit. Kind of like how the moon only shows one face to Earth. One side is perma-frozen darkness, and the other side stays hot and sunny. But touching down here won't be any kind of tropical vacation for Voyager 1. More like an uncontrolled crash. Pulled by the planet's gravity when it came too close, Voyager wouldn't spiral to the ground. It would hit the atmosphere like a bullet. The entry velocity would be around 20 kilometers per second. With no heat shield, the probe would vaporize instantly. The cameras, booms, a high-gain antenna would melt. Only the general-purpose heat source modules, the heavy-duty shells around the nuclear batteries, would survive. Any leftover particles from the burnt-up metals would eventually cool and become dust in the wind. Stellar wind. Unlike terrestrial winds on Earth caused by the movement of air, these gusts would be more like hot flows of gases sneezed onto Proxima Centauri by its star. Then it would be time to face the music. On the golden record. Remember that 1977 phonograph hitching a ride on the Voyager 1? Just waiting for its debut release in the cosmos? It's been holding on to everything from sound recordings of insects to a message from then President Jimmy Carter, and a plethora of bangers from artists like Mozart, Louis Armstrong, and Chuck Berry. Now, I personally think that Bruce Springsteen's Born to Run would have been a better choice to display the sheer greatness of human achievement, but I wasn't consulted. The committee that put it together was headed up by famed astronomer Carl Sagan. They also chose snapshots of life on Earth to put on the golden record. Human sex organs, Taj Mahal, a woman eating ice cream, sailboats, daffodils. Heck, when you look at it that way, life on Earth isn't so bad. That's because the committee also made a conscious decision not to include any photos of crime, poverty, disease, or war. It's like Earth put together a dating app profile, only showing its good side, holding up a fish. A little biased, but who doesn't want to put their best foot forward? Am I right? But back to the phonograph. The good news, it's fared better in space than it would have on Earth, with less to erode it. The bad news? Well, after 75,000 years in the ether, it would be blasted by interstellar dust and lose all of its data. So that recording of crickets would now just be crickets. Oh, the irony. While the high-frequency data might be sanded off by dust, the record itself is incredibly dense, and since the golden record is technically gold-plated copper housed in an aluminum jacket, it wouldn't necessarily be destroyed by the atmospheric entry. It may actually be the only thing that survives a total meltdown. But there's no doubt it would be a little worse for wear, most definitely warped or even buried by the impact. But what if an alien civilization found this long-lost remnant of Voyager? While they might not be able to rock out to Johnny Be Good, if they were advanced enough, they could determine where the probe came from. And that's thanks to a hidden message on the cover of the Golden Record. Pulsar map. The starburst-like engraving is like a cosmic GPS showing exactly where the sun is, located relative to 14 pulsars. These pulsars are the spinning remains of dying stars, and they act like lighthouses when their magnetic fields cause them to emit beams of light. If extraterrestrial light could decipher the map, well, it would be like finding a cosmic return to sender address. It's important to keep in mind that what we know about Proxima Centauri B today might be different in 75,000 years. Scientists can really only make their best estimates about what its atmosphere is really like. So, just for fun, let's say that Voyager 1 somehow survived its journey to the exoplanet. Well, it would take 4 light years, 40,000 Earth years, for its signal to reach our planet, and another 4 light years for Voyager 1 to receive anything back. But even if humans could whisper some sweet nothings to Voyager 1, sadly it would be doomed. Though it was designed to carry a message for extraterrestrial life, it just wasn't designed to stay on an alien planet full time. And though it may not rust away like it might on Earth, it would likely meet its match eventually with some kind of catastrophic impact. Given that some scientists suspect that there could be an asteroid belt near Proxima Centauri B, pounding rocks at the planet, things aren't looking too good for Voyager 1. But then again, as the saying goes, life's about the journey, not the destination, right? So, for the spacecraft that's made the furthest trip known to us, broken countless records, and shared fascinating clues about the uncharted depths of interstellar space, I'd say it had a pretty damn good ride. And now, what if that alien civilization reached Earth and attacked us? Well, that's a story for another What If.